Thank you for selecting this presentation. So I'll be presenting an exploratory analysis from the patch trauma trial, and most of the background has already been presented today morning. So I'll just briefly go over it. So trauma is one of the leading causes of death globally, and most of the preventable deaths following trauma are due to bleeding. And tranexamic acid, which is an antifibrillary agent, has been shown to reduce the risk of death following major trauma. So one of the largest trials, the CRASH-2 trials in this space, showed that TXA safely reduced the risk of death in bleeding trauma patients. And a subsequent exploratory analysis demonstrated that the mortality benefit was associated with time between injury and first TXA dose. And it was shown that the early administration of TXA, that is within 3 hours, significantly reduced the risk of death. But when given after 3 hours, it seems to increase the risk of death. Another trial, the STOMP trial, did not show any significant reduction in mortality at 30 days. But in a subgroup analysis, it did show a significant survival benefit when TXA was given within 1 hour of injury. You have already heard about the patch trial, which included suspected severe trauma patients at high risk of trauma-induced coagulability, who were randomized in 1:1 ratio to receive tranexamic acid or placebo. And the primary outcome was survival with favorable functional outcomes at 6 months. And the secondary outcomes were death within 24 hours, death within 28 days, and death within 6 months. What has already been presented, TXA did not result in a greater number of patients surviving with a favorable functional outcome, but it did show a significant reduction in the risk of death within 28 days from injury. So our aim was to determine whether the death within 28 days after trauma varied according to time from injury to the first TXA dose in the patch trauma trial, and if so, precisely determine the therapeutic window. So to do this analysis, we used a multivariable fractional polynomial interaction algorithm. We evaluated the association of time from injury to TXA or placebo on a continuous scale as a linear function or nonlinear function using first and second degree fractional polynomial transformations. And we evaluated the interaction test using a likelihood ratio test. And we evaluated the outcomes, death within 28 days after injury, and vascular occlusive events and sepsis. So of the 1,310 patients which were enrolled and underwent randomization in the patch trauma trial, we excluded patients who withdrew their consent or had missing data. Of these, 1,287 patients had complete data for analysis and were included for ITT analysis. So here are the baseline characteristics. 635 patients in the placebo group, 652 patients in the TXA group. The time from injury to first dose of tranexamic acid or placebo in minutes, which was the variable of interest, was balanced between these groups. The median time was 80 minutes in the placebo group and 77 minutes in the TXA group. And this is a treatment effect plot showing the association of time from injury to placebo or TXA to death within 28 days. On the x-axis, you have time from injury in minutes. On the y-axis, you have the risk ratio. The solid gray line at 1 is the line of equivalence. The solid black line here is the point estimate for treatment effect. And the dotted lines are the upper and lower 95% confidence intervals. And you see an interaction p-value of 0.02. So there is an association of time from injury to risk of death. And what we also see is that the upper 95% confidence interval crosses 1 just around 90 minutes, so suggesting that there is benefit or risk reduction when TXA is given within 90 minutes. It crosses, the point estimate crosses 1 at around 120 minutes, and beyond 90 minutes, we do not see a good evidence of reduction in risk of death. So we also used the 90 minutes as a cut point and did further subgroup analysis. So in patients who received TXA within 90 minutes, we do see a risk reduction with a relative risk of 0.64 and a 95% confidence interval of 0.50 to 0.82. The rate of death was 25% in the placebo group, 17% in the TXA group, an absolute risk reduction of 8%. In the group of patients who received TXA beyond 90 minutes, we do not see any good evidence of risk of reduction of death, with an adjusted risk ratio of 1.04 and a 95% confidence interval of 0.74 to 1.47. When we look at vascular occlusive events in sepsis, we did not find any evidence of heterogeneity. All the interaction p-values were greater than 1 for both vascular occlusive events and sepsis. So if you look at all the data with the two previous trials, so the CRASH-2 trial, the STAMP, and this study. So the CRASH-2 trial reported their interaction p-value. It was less than 0.001. The STAMP trial did not report an interaction p-value. And in this trial, we report a p-value of 0.02 for interaction. If you look at the risk ratio in the subgroup of patients who received TXA within 1 hour, we see the point estimate is largely similar. It is 0.68 in the CRASH-2 trial, 0.60 in the STAMP trial, and 0.61 in the study of PATCH trial. So in conclusion, the optimal window of opportunity to reduce 28-day mortality among severely injured trauma patients requires TXA to be administered within 90 minutes of injury. The observed therapeutic window is consistent with the time-dependent effects observed in the STAMP trial, and the therapeutic window is half as long as the 3-hour window concluded in the exploratory analysis of the CRASH-2 trial. And trauma resuscitation guidelines focused on preventing early death should incorporate TXA administered within 90 minutes of injury. So thank you. And I would like to acknowledge all the patients who were enrolled in this trial and all the investigators who conducted this trial.